Hello everyone, welcome to the problem session of magnetism part. This is the problem number 53, chapter 29 from Resnick, Halliday, Walker. In this problem we said that there is a long solenoid, has a 100 turn per centimeter and carries a current I. This figure is basically the diagram, is not exact figure of that one. An electron moves within that solenoid in a circle of radius 2.3, that actually 2.3 centimeter, which I try to draw inside that solenoid over here if you observe. So this is actually that electron. I draw that schematic diagram, and this is actually perpendicular to the axis of solenoid, because this is actually that axis, red line actually showing the axis of that solenoid. Now the speed of this electron is 0.0460 c. This is the speed of the light. Now we have to find out the current into that solenoid, which is the I. Now if we write down that parameter is the given over here, say for example if I write that speed of that electron, which is 0.0460 c, that radius of circular track of the electron which is within that solenoid, which is 2.3 centimeter, that means 2.3 into 10 to the minus 2 meter, and number of turn into that wire of into that solenoid, which is actually 100 turns per centimeter. So if I convert that is to the 100 into the meter, that should be 100 turns per 10 to the 2 meter. So that means N would be basically 10,000 turn per meter. Fine. So due to that current into that wire of the solenoid, it will create a magnetic field inside that solenoid, and the direction of that magnetic field would be towards that rightward. So if you can find out, right, if you put your thumb in the direction of the current and try to rotate, then the rest of the finger will give you the direction of the magnetic field due to that one. So since over here, so this is the direction of the current, if I put my thumb over there, and then my rest of the finger will be towards that direction, inside towards right hand side of that axis actually. So that's why that magnetic field will be towards that right hand, towards the rightward. And the strength of that magnetic field we can find out from that formula. So B would be mu naught I into N, where mu is the permeability of that medium, I is the current, and N is the number of turn per unit length. Fine. Now due to that magnetic field, it will also create a force, magnetic force onto that electron. So what would be the direction of that magnetic force onto that electron? To find out that direction, what I'm going to draw, say it's an electron actually the revolving in that direction. Then over here, so this is would be direction of that velocity, right, of that electron, and this is would be that magnetic field, which is basically that downward direction, right? I just shifted that one. So this is would be my direction of that magnetic field. Now we can find out if we put our right hand rule over here. So this is actually that velocity of that electron, and this is actually that magnetic field. Then magnetic force over here would be basically out of the base or out of the board, right? If you put your first finger or forefinger towards the first vector, which is basically velocity of that electron. And if you put your palm towards the direction of the second vector, which is the magnetic field, so that's mean if you put your palm towards the magnetic field, then if you rotate rest of the finger towards the second vector, then your thumb would be basically out of the base or out of the screen. So that convention for the positive charge, since it's an electron, it's a negative charge, so that's why I can say that magnetic force over here would be into the base. So that would be that magnetic force direction. Fine. So that's mean magnetic force onto that electron would be into the base, or I can say towards the center of this circular track, right? So this would be basically direction of that magnetic force. Now, since the electron is revolving in a circular track, so there will be also a force towards that opposite direction, which is actually centrifugal force. We can say that these two forces is going to the balance is out, right? So we can write in that case Fc, centrifugal force, must be equal to Fm. I'm writing that magnitude. So if we write, or you can write down in terms of vector actually. So if I write, so this is would be mv square into r head actually radially outward towards that direction. If you consider this is the radius of that circular track, then Fm we can write it should be minus q into b cross b into also r head towards the center of this one. So that's why I use that r head over here. This r head will be cancelled out. I can cancel out this r head, and I can write down this magnitude basically from there. I can write it will be mv square over r, and I am writing v cross b into angle sine 90 degree, right? This is actually, I'm taking the magnitude of this one, then I will find out it would be mv square over r would be q, and this charge of the electron is still basically the negative. You can also put negative, that's minus is also going to the plus. It doesn't a big deal over here, right? If you use that convention plus and minus sign. So that's why you can find out this is going to be the positive, though v the speed of the electron into v, and sine 90 basically the 1, and this would be 1v would be cancelled out from there. This is going to be the v over r into q. Q is the charge of that electron into b. Now this v, which is the magnetic field of that solenoid, which is actually towards the downward, this is the direction of that magnetic field inside the solenoid, that I could write using that formula. I write mu naught I into n. It will be equal to mu naught I into n. From there I'm going to find out that current I, right? In that case I would be basically mv, which is actually the momentum of that electron, into r q mu naught into n, where n is the number of turns. Now I'm going to plug in the value of this parameter, which is mass of the electron is 9.11 into 10 to the minus 31 kg. Speed of the electron is the 0.4046 into c. C is 3 into 10 to the power 8 meter per second. That is the speed of the light. R is 2.3 centimeter, which I convert to the meter into 10 to the minus 2. Charge of the electron is 1.6 into 10 to the minus 19. I didn't use the minus sign because this minus and there is a minus sign, that's going to be the plus over here, and that's why I neglect that minus sign, into mu naught, which is 4 pi into 10 to the power minus 7. That's the constant that would be given, and that n, which is 10,000 per meter. Now if you solve this one, you will find out that I is going to be basically 0.2 0.72 ampere. So that should be the current into that wire of this solenoid. This is the answer of this question. Thank you very much.